Thank you very much, and I think those talks just before have teed me up very nicely for what I'm going to talk about. Now, we know that the start of this calf's life will either be a springboard for her or it will be a complete setback. And yet, calf management and the environment in which we place our calves in is often overlooked, and that results in respiratory disease, diarrhea, poor growth rates, and high treatment costs. But if we can focus on getting the basics right, and we can focus on that environment in which we place that calf in, we not only reduce disease on farm, but we actually set her up for a productive future. And it was about 3 years ago when I really started to focus on the environment in which we place our calves in. And it fascinated me because when she gets sick, it doesn't just matter on that day. Actually, that incidence of disease can be carried with her throughout her productive life. And then you bring the word sustainability into the mix, a big word in agriculture. And actually, if you bring that back down to farm level, a healthier animal is a more productive animal, it's a more profitable animal, but not only that, it's a more sustainable animal. And if we focus on calf rearing, and I love to use this multifactorial triangle, and actually it comes perfectly into what Tim was saying, but you've got your calf, the immunity of that calf, the colostrum management, you've then got your pathogens, so what disease are you up against on farm? And then you've got your environment in which you place that calf in. And if you look at the research and the factors that make for successful calf rearing, they fit perfectly around this multifactorial triangle. So you've got your age range, your milk quality and quantity, colostrum management, disease detection and treatment, bedding and drainage, ventilation, stocking density, and hygiene. And if we can get that all right, you get your super calf. And this is my use of using AI of what AI thinks a super calf looks like. However, we still have a massive problem. We know that respiratory disease is one of the most common causes of morbidity and mortality in calves. And actually, new studies show that nearly a third of all calves in the UK are suffering with respiratory disease. And it was just touched on briefly there, but lung scanning. Very traditionally, we see a sick calf on farm, and you treat that calf. However, these new techniques, what they're showing is actually a lot of calves are having subclinical respiratory disease cases. Therefore, they are having lung damage and lung consolidation without actually presenting any clinical signs of that disease. And when you think of lung consolidation, if you think of a sponge, and the lungs being like a sponge and they contract in and out, and you rub that sponge in mud, and then it dries, that's lung consolidation. And actually, we know, research is showing, that even 1 centimetre of lung consolidation can result in poor growth rates, daily live weight gains, and that will affect daily milk yields going into the future herd. And yet, this is where we're housing our calves. If you go around the UK, very typically, we're housing in quite cold, damp environments, poor airflow, inconsistency, quite dark. And when I was going around farms and I really started this focus on the environment, and I was looking at this and I was thinking, there must be a better way, or what is the optimal environment to place our calves in? And I was speaking to vets, and nobody really had a solution. So it was myself and 2 colleagues, we got together and we thought, okay, hypothetically, if we had to create the perfect or the optimal calf unit from scratch, what would it look like? And we drew it on a whiteboard, and this is what we came up with. We got some funding, we teamed up with SIUC, and most importantly, we teamed up with Ross, the farmer, and we designed a cost-effective, ventilated environment for calves. And the building and the system, last year you might have heard my colleague talk on a holistic approach to calf housing, and it was very much using all of these principles in designing the system. And it was built around the latest research, and we were advised in many different ways, but also, most importantly, it was built with the farmer. And his key to this building is that he's got 3 daughters he wants to take over his farm, and he wants that to be appealing for them. And so this system had to be efficient. It had to have labour savings, and it had to be easy to do. And that's exactly what we've tried to aim for here. However, you might look at this and you might think, that's the gold standard on farm. You know, we could never have that on my farm. However, and this is why I love Youngstock housing so much, these principles that we've taken and put into this building, and the principles and experience that I've learned putting up this building, actually, it can go and be put on any other new build that's being built or any retro build. And it's those principles that we can take away and implement then on many different systems. So if we can break that down into 3 blocks, we've got airflow and ventilation, your temperature and humidity, and that social housing and stocking density. Ventilation. What is ventilation? It's the precision of fresh air into a building space. That will displace pathogens, noxious gases, temperature and humidity. We know that most bacteria, viruses and fungi like to survive on dust particles and water droplets. So if that air in that building is not being exchanged, that is what your calf is going to be breathing in. The more humid that environment, the more survivability that those pathogens have, but also the smaller the water droplets, allowing deeper penetration into the lungs. Now, hold with me here, because I know what a lot of you are going to think. Calves don't produce enough heat, but I'll come back to it. How does natural ventilation work? It's the most common cause of use of ventilation we use it within the UK. That animal produces heat, that hot air is less dense, so it rises, and that draws in clean, fresh air from the outside. You've also got help of your prevailing winds, and you've got your exhaust. And that is what we all call a stack effect, and it works perfectly with our older stock. I'll come on to this later, but let's not overlook it for calves, and I'll come back to my reasonings. In order to get natural ventilation to work, you need no wind shadows, you need an interior roof slope, you need an exhaust, you need side inlets, and you need the building to be orientated correctly. When I say no wind shadows, what do I mean by that? Well, I mean, in the UK, we like to take a really perfectly good building, and then we think we want to expand the farm, so we'll get a builder in, and they'll say that we'll put another building here and another building here. And eventually, that building, you've limited all your natural airflow to it. And it was a few years ago, I was on a farm, and he said to me, and this is just a great way to remember it, he said, we're all morons because we're adding more on. And I thought that was a brilliant way to remember and think about it in that kind of way. You need an exhaust, you need the side inlets, that's where your air's entering the building, your roof slope, and that building needs to be orientated perpendicular to your prevailing wind. So your wind can come perpendicular to that ridge and aid that movement. However, when you think about calf ventilation, it's not just about ventilating that building space, it's about ventilating that calf's microclimate. And it was actually a study looking at respiratory disease in naturally ventilated barns, and it was done in the US, and what it found is lower respiratory disease with lower airborne bacterial counts in pens. But the co-founding study finding was that if you put solid panels between pens, you get a lower respiratory disease, but you get an increase in airborne bacterial counts. And this is what has stimulated the work to produce positive pressure tube ventilation systems. And it's all about pushing fresh air into that calf's microclimate. And they work great because it's all about delivering fresh air at the correct speed and height. Now, these tubes should be designed to deliver your minimum air exchanges and air speed during the winter months and the colder weather. So these tubes should be getting 0.25 meters per second at calf lying height. In the summer months, however, you would like that to increase to about 1.3. You then think of the air exchanges. These tubes should be achieving 4 to 8 air exchanges. In the summer months, you then want that to increase to 40 to 60. And that's where your natural ventilation mustn't be forgotten about. Your tube does your basic minimum through your winter months and through those colder months, and that allows you to close that building up and try and keep that temperature. But the importance of being able to open that building up, get that higher air exchange, and that air speed is really important, and particularly given the weather we've just had a few weeks ago. It is not just older stock that suffer with heat stress. And then, to put it back to that natural ventilation stack effect, this is how I like to think of how when you implement a tube into a calf building, it pushes fresh air down. That calf will still be producing a bit of heat, that hot air will go up and it will be expelled through the inlet or the ridge. So it's also really important that you've got an exhaust to get rid of that stale, dirty air. And there's a study which shows that calves without positive pressure tube ventilation systems in their housed environment are 80.6% more likely to get sick than if they did have it. And it is being implemented by the industry as a whole, and actually, as an advisor, I advise it goes in any new build going up and any old build. So how do we implement that into our new building, or if you're implementing it on all those ventilation principles, if you're implementing it on your farm? Upwind of older stock. This is often also really overlooked. This is the farm where we're doing our project, and actually, originally, he wanted to put the building here. And we said to him, you're better off investing your money into a greenfield site and having it here, because that is where the prevailing wind is hitting your farm. You do not want your prevailing wind going through all your older stock before it then reaches your calf building. We built the whole building with ventilation at its core. So we've got the prevailing wind coming perpendicular, using that ridge. On the back of the building, we've got a side curtain, which can open in the summer months to get that air exchange. And then at the front, you've got your sheeted gate with a pull-down blind. Again, that opportunity to open that building up during the summer months. And then you've got your tube. And this video shows where I've put smoke down the tube, and it gets really, really great visual way to see if that fresh air is getting to calf height and into every corner of that pen. And then you want that dirty air to then rise up and expel out of the building. Moving on to temperature and humidity. When we think about temperature, you think of the thermal neutral zone of the calf. And that is where the lower critical temperature is around 15 degrees, and then your upper critical temperature is around 25, even though I've listened to some talks recently which actually might determine that higher critical temperature could be a bit lower. And think about your lower critical temperature. Anything below that temperature, that calf will have to use its feed to keep warm. So that feed is not going to growth and it's not going to immunity. Now, if you then place that calf on a damp bed, that lower critical temperature will rise by 6 degrees. If that calf is then in a drafty environment, that lower critical temperature can rise by 9 degrees. So if your calf is on a damp bed and it's in a drafty building, your lower critical temperature could double to 30 degrees. And I think that's a really important message of how important that environment in which we place our calves in is. And again, also to think about heat stress and that upper end of it. Anything over, really, we're looking about 25 degrees, will cause heat stress on that calf. Okay, and how do you implement that on farm? So this top picture is calves in quite a normal building, and you've got spaceboarding here. There is a difference between spaceboarding and Yorkshire boarding. Spaceboarding is your boarding like that. Yorkshire boarding is where it alternates. Here, you had your prevailing wind coming through here. The prevailing wind was coming at about 5 meters a second, so quite high. When that cold air enters the building, it drops. So what you get here is cold air coming in and dropping down onto the calves. Calves like to lie against something solid, so here you're causing a stress. Little solutions create microclimates in that building. Heat lamps. A study by the University of Nottingham showed heat lamps to have the biggest effect on daily life weight gains for calves. And obviously you've got the extra cost of putting them in, but actually the return on them can be really successful. The materials in which we build our calf sheds, for years we've built our calf sheds with concrete. Concrete draws heat away from that calf. So starting to think about what your calf is lying against, some sort of plastic paneling to not draw that heat out, but also from a hygiene point of view, really easy to clean down and disinfect. And then again, microclimates down here, calf jackets, and nesting scores. We know that a higher nesting score, which is how, when you bedded up your calf, how much that calf can nest within that straw, higher nesting scores is associated with lower respiratory disease. And this comes from some research in the US, and actually they say that a calf jacket can equate for a 1 on the nesting score system. There is some confounding research with that from the University of Nottingham, where they actually found that calf jackets didn't actually have any influence on daily live weight gains. But I think actually, when they're managed right, they can work well. Moisture. And one of my favourite sayings is you can have the best building in the world, it can be ventilating and amazing, it can be brand spanking new. If you've got moisture underfoot and it's damp, you will always have problems. That is a breeding ground for pathogens. And the biggest challenge we've got in the UK, actually, is we've got really high humidity rates. So most of the year, we won't really see it get below 50% humidity. Trying to get that moisture out of the pen, out of the calf environment, all it will be doing is making that calf cold. It'll be sitting there, you'll be getting ammonia off that, and you will subsequently always have problems on farm. And so how do you do that? You put a good slope and a good fall on your pen. And that is now recommended to have a 5% slope on your building. And yes, that is a lot of concrete. And I was on farm a few weeks ago, and he had a brand new building put up. It was a very, very good building. And he'd been advised to put a 5% slope on the concrete. And he said, as it went in, he looked at it and he said, that's a lot of money. I'm not doing that. I'm going to put 2% slope on. And he looked me in the eye and he said, that is the biggest mistake I have made, because he's got problems. So that bedding area is not draining. It's not getting moisture away from the calf. Equally important to get moisture out of the bedding area and then out of the building. So making sure that front drain is taking that moisture away. Social housing. Now, traditionally, we house our calves like this, and actually we forget calves are social animals, they're herd animals. And it is being thought of a lot now. And why have we done it like that traditionally? From a management point of view, it's easier. We believe that from a disease point of view, it might have helped limit disease on farm. But actually, if we look at the research, what are the benefits of social housing, paired housing, group housing? Cognitive development. We know that if that calf is paired with a friend, that they are more adaptable, they learn quicker, and that cognitive development is better. And especially now we're thinking of the future of agriculture and what we're going into, we're wanting our animals to be milked on robots, to have a lot of technology. So it's really important that we get that cognitive development right from the start. And that ties into the welfare point of view as well. They're meant to be housed together. They are herd animals, so it all ties in with that. If we look at the growth and feed and the various amount of studies done, what we found is a number of studies have found no difference. So whether they're individually housed or paired or grouped, there isn't actually any difference. But a lot of studies have found positive benefits of it. But the key message there is actually there have been no negative studies found on growth rates and feed rates. Calf health. When we talk about calf health, it's very much down to colostrum, it's down to housing, it's down to management. And the studies on whether individual housing to group housing do vary. The diarrhea tends to show lower in paired or grouped housing. With respiratory disease, there are mixed results. Consumer perception, something that we also don't talk about much, but a study done in America actually found over 50% of the people who took part in the study disapproved of individually housed calves. And I think that's a really important, at the end of the day, that's our end customer, so it's really important to consider that. And then if we look at how we then can group those calves, Smaller groups are better. However, we are now feeding on automatic feeders, so you have to make that feeder pay. Faster fill, and you can get them emptied quicker, and it's that all-in, all-out system. The maximum days to filling a group should be around 21 days. Even if that group is not filled, you're better off cutting it off and starting a new group than continuing to fill until you reach your group maximum. But I can't stress enough the importance of having an all-in, all-out pens. When those calves go into that building, they go into that pen, and they don't move until then they leave that building, and that is cleaned and disinfected. Stocking density. We know, and the study the figures on the presentation before, I'm going to contradict a little bit, that the black line shows less well-ventilated housing system, and the bottom one shows a well-ventilated housing system. And we know that the more space we give our calves, the less airborne bacterial counts there will be. No matter how good your ventilation is, can never make up for your stocking density. If you double your stocking density, your ventilation rate in that building needs to increase by tenfold to keep the same air quality. And so if you're pushing too many calves through your system, you will always have problems again. So I know that we have to look at costs, and we have to look at making the systems pay, but it's worth thinking about the long-term costs of pushing too many calves into a building. So what is that? So actually the optimum, and this comes from the Dairyland Initiative in the US, we're now looking at 3.3 meters squared per animal, which seems like a lot. And what does that look like? Well, that's 1.8, and that's around 2.6. So that's just a visual of how the space in which a calf needs. But I can't stress enough, stocking density will have such an impact on your farm. And how have we made that work in our building, on how you can make it work? So when the calf is born, she comes into these boxes. Now, Ross the farmer is coming out of a hutch system. So for the first 3 days, he wants that calf to be individual in order for them to get their colostrum. However, this middle panel can then be taken out, and that calf is then paired housed. And in that middle panel, that calf can actually see the calf next to it. When they first come into the building, they have this heater on. And it's something that I saw at Total Dairy, and it's basically almost like a hairdryer, and it's drying that calf out in the first 24 hours. We know that can have really good benefit on colostrum uptake, and also just giving that calf the best start. About 5 days, they're then being moved into the group pens, and that's just because of how it works with Ross wanting to get them onto the feeder quicker. And the group pens are made to take 15 calves, but at the moment, with Ross's management, he's getting about 12 in each pen. My final point is lighting. Now, as a lot of you may see, this is a fabric building. I like to call it a glorified polytunnel. And it creates a really nice light environment in there. And I think lighting's often really forgotten about with calves, especially from a welfare point of view. But we house our calves in quite dark and dingy environments. And actually, providing the right lux can have a really good impact on hormone production and overall well-being of that calf. But one thing that we have had a benefit from with this building is actually, on a cold winter's day, when the sun is shining, you will find that it will be colder in your building, in your calf building, than outside. And one benefit we were finding from this building is that actually you have, when this shows 2 overcast days and the temperature within the pens in the building, when the lux levels increase, we actually find that the internal temperature in that building increases as well. So we're getting thermal gain during the winter months. And that shows the delta temperatures from 2 different pens in the building, so the difference between internal and external. So we're getting a good positive 6 degrees. And I know what you're also going to say. What about the 30-degree heat we've just had? Well, we've also looked at that, and now I come back to my importance of air exchanges in the building. We looked at a hot period in May, And we found that the building will always stay about 2 degrees warmer than external during the summer months. But we had one period in our housing where the curtains didn't work due to technical faults. And actually, during that period when the air exchanges weren't being taken place, that 2 degrees turned to 6 to 9 degrees. So I can't emphasize enough how important it is to get your air exchanges to keep that temperature regulation in your building. And that is where your tube will do your minimum, but you're opening the building up, that will be what you can maximize that performance through the summer months as well. And finally, just to touch on, what are we doing in our building? So we're doing a calf trial, and we're monitoring the calves going through his old system, which is the hutch system, and then the calves going through our building. And we're looking at health performance, the labour savings, and carbon footprint. Now, the trial finishes in September, but what we're finding, we're lung scanning everything going into the building through the hutch system and through our building, and then it's lung scanned on exit. And what we're finding is everything that's going into the hutch system in terms of lung scanning, those lung scanning scores are we're having a higher rate of 4s and 5s leaving the building, leaving the hutches, whereas with our building, they're staying at that 1-2 level. They don't tend to worsen through that whole period. But we'll have some more solid findings on our results in September when the trial finishes. So to recap on those pillars of performance, you've got your airflow and ventilation, your temperature and humidity, and then that social housing and stocking. And when I go on farm and I'm doing my advisory visits, what am I looking for? One thing that I can't stress enough is put yourself in that calf position. And it sounds silly, but last week I was doing an advisory down in Dorset, and I was stood in the back of the pen, and I said, God, it's hot in here. I said, no, it's not that hot. So we stood there, myself, the vet, the farmer, for about 15 minutes. And after 15 minutes, he went, God, it's hot in here. Put yourself in that calf position. Kneel down. Are you getting damp knees when you kneel down? Is it cold? Is it drafty? And measure it. If you don't measure it, you can't monitor it. Now, I'm going to leave you with one more message. And this is from Ross, the farmer who we've done our project with. Optimising your housing will play a really important role in health, welfare and performance. However, good housing is not a cure for poor management. And I think that's really important to remember. Thank you very much.